Hello, everyone, and welcome to our last Dr. Spotfire session of the year. I'm your host, Jose Levi Aguirre, and today I'm joined by Michael O'Connell, Spotfire Chief Analytical Officer, and Ben Shneiderman, Emeritus Distinguished University Professor of the Department of Computer Science at University of Maryland. You want to say hi to the audience, guys?
Hello.
Hey, welcome, Ben. Hi, everybody.
The happy world of Spotfire.
Yeah.
Indeed.
All right, that's awesome.
It's great to have everybody on board here, Jose and Ben.
Yeah, thank you. Okay, so let's continue. This is a quick confidentiality and disclaimer. You can pause and read it through. This session is going to be recorded, and it's also live, so make the questions coming up. Every question is welcome because our motto is learning is not driven by answers, but by questions. So to keep the questions coming, they spark curiosity and leads to a deeper understanding. Questions that challenge others to think critically, to seek answers that drives the learning process. So in this session, again, we're covering Spotfire Treemaps with our special guest, Ben Shneiderman, and Spotfire Chief Analytical Officer, Michael O'Connell. So Ben Shneiderman is a distinguished university professor in the Department of Computer Science, founding director 1983 to 2000 of the Human Computer Interaction Laboratory, and a member of the Institute of Advanced Computer Studies at the University of Maryland, College Park. He's a pioneer in the field of information visualization and originated the tree map concept for visualizing hierarchical data. So for everyone, just to be on the same page and those who are not new to Spotfire, so Spotfire is a visual data science platform that empowers experts by integrating advanced analytics with specialized industry visualizations to solve complex business challenges. And with that, let's go through the agenda real quick. We're going to cover the origins of the tree map from its invention and early days with the Spotfire, and to all the way to the recognition in the Museum of Modern Art. And we'll then introduce the related Marimekko Chart, custom visualization, also known as visualization mods, and before concluding with practical high-value tree map use cases across the energy, manufacturing, and finance industries. So let's go to the overview. Ben, how did the tree map got started?
Right. Thank you very much. Yeah, the tree map story is a quite wonderful one. Very satisfying. In the days of the 1990s, a long time ago, we were looking at inventing new different kind of visualizations. And one of the challenges we faced, we always found that we made best progress when we worked on a real problem that we cared about. Exploring hierarchical structures was a difficult thing in those days. They were the link and node diagrams, which sprawled over many screens and pages, and you really had trouble exploring them. And so we were looking at a way to find or explore your hierarchical directory of the files on your machines. And it was an important problem because in our lab, we had a Mac at the time with 80 gigabytes, which was a lot, and it would fill up. And so I had to find out who of the 14 users had been taking the most amount of storage. And so I worked it was more than 6 months on many different versions. And then one day in the faculty coffee lounge, I had this aha moment. It's a classic story of vision, of percolation, the idea of percolation, then the aha moment when you make this creative breakthrough. And it took me 3 days to convince myself that it really worked. And I wrote the 6 lines of recursive code to make it run. And so this was an early version implemented on a Mac, which showed the hierarchy of the history folder on my drive, 1991, 92, 93, 94 across the top. And then each file was shown as a rectangle. The size of the rectangle was the number of bytes, and the color was the type of file. So texts were green, graphics were lighter green, archives and stacks were blue, programming and colors were represented. You're seeing a small part of the drive here, but this is very powerful because you can see which files are taking the most space. And so that was a really important idea. I had trouble convincing people that this was a good idea. And I had a memorable encounter at the University of Washington where I went to present this to some wonderful colleagues who were really very capable people. And I showed them this, and they looked at me as if I was crazy. They couldn't quite make sense of this. And so I went with them. I said, come with me. I went to their laboratory, and they had a Mac, and I put the disk in, and I popped up the screen, and there was just, there was this astonishment moment. They suddenly could see that there were 3 copies of the C compiler on this machine, eating a large part of the space. And so it immediately made the case. So don't talk, but show is the usual message. And that's a very important Spotfire message, where every time you want to win people over, show them the pictures, show them the screens.
Show them the data. Show them the data. And I think, Ben, didn't when you were doing this and you originally did it on the Mac, didn't you have some luminaries visit the lab at one point? Like, didn't Steve Jobs show up?
We did. We were an early pioneer in the world of human-computer interaction, and Steve Jobs did come visit our lab, and we arranged demos for him, and he was already quite the figure in those days. And he went very quickly from one demo to the next. That's great. That's great. That sucks. That's great. That sucks. There was nothing in between. When we asked him why, he did have reasons, and he wasn't always right. But it was an amazing encounter, and I became a consultant for Apple for 5 years in that period. And later in that same period, when we were working around Treemaps and other visualization designs, it was an exciting time. Chris Ohlberg had engaged us from his home in Sweden, in Gothenburg, and he came to visit, spent the summer of 1991. We'll talk about that in a while. And again, the summer of 93. And that's those 2 times we produced a wonderful set of papers, which have been very influential. So yes, it was a lively time for us, and it came together because we had some wonderful people and wonderful students. When people ask me what am I most proud of, which of these innovations, it's always easy for me to answer my students. That's what makes things happen. And so Chris was a wonderful partner and student who worked together with us, and that's how we came to develop the ideas that were bubbling in the lab into something focused in a commercial product, which he called Spotfire.
Fantastic. Well, Jose, go to the next slide and tell us a bit about how that happened.
Right.
And
one of the early, visualizations that Chris built during the summer of 1991 was a periodic table of elements. And, as you can see in the lower center, some of the elements are highlighted red and some are just grayed out. And they're indicated by the 6 sliders on the bottom of the screen. And so you can easily explore and come to understand the relationship of the periodic table of elements to the visualization sliders like the ionization energy and other chemical properties. And for me, it was just a real eye-opener in terms of understanding the chemistry in a way I never did before. We brought in colleagues from the chemistry department and PhD students, and they spent hours exploring this because they had never seen their data, the world of periodic table of elements in this revealing way. And they could understand how the pattern, why the periodic table made so much sense. And they found new relationships that they did not understand before. So that was a real eye-opener and led to other projects like the Film Finder, which was another early one that Christopher Ohlberg implemented. And so we were developing these ideas. You can see in the periodic table, there's only single box sliders. You only have one slider to go to above or below. And so we felt it was necessary to have a double box slider. And that's where we developed these dynamic queries that became a key distinguishing feature of Spotfire because it had double box sliders. And we explored the ways double box sliders could be used and implemented. There were quite a few variations. There were other wonderful students. Another Christopher Williamson, was working at the time and made the Home Finder, another one of our tools that got a lot of attention because people had never been able to explore data in this rapid, interactive way. It was a step forward because we were good at the database and the implementation side. And so making these things work with millisecond timing was a challenge on machines of that time. And we were able to succeed in doing that. And it really opened people's eyes to the potential for interactive visualizations in the way that, Jose was showing that 3D slide, image at the beginning, and you could rotate it and move it. That was astonishing 30 years ago. And so, we were able to produce that kind of success. Chris and his buddies formed Spotfire, and I joined the group as on the board of directors for 5 years. And so it was a very satisfying time. And just, they had the good energy. They taught me lots about business that I needed to learn.
And you were there, Ben, when Spotfire was launched into the pharmaceutical R&D area, and you saw some of the early work that's being shown, like the molecule visualizations and the human genome data.
Yes, and also high throughput chemical analyses outputs. And Christopher understood the way he taught me about the book Crossing the Chasm by Jeffrey Moore, which talked about the process by staying with the vertical of chemistry and pharmaceuticals first. And Chris would get on a plane twice a week, fly somewhere, give a talk, give the same talk, come back, and for dinner if he could. And he would just get out there and keep pushing on those particular market segments. So he implemented the business approach in a very effective way.
Fantastic.
And I was out there writing papers and speaking to academic groups, which gave us a different kind of input. But Chris showed me that, what we really needed are people who had checkbooks, as he said.
Yeah, no, that Crossing the Chasm is a real great book, and that was the design Spotfire to cross the chasm in pharmaceutical, and we very quickly went to energy sector and manufacturing after that. But along the way, Ben continued the academic work at University of Maryland, and on the Treemap side of things, all of a sudden, Ben was able to get various Treemaps on an artistic flavor inducted into the Museum of Modern Art. And so, Ben, why don't you tell us a bit about that project?
Yeah, that was another satisfying project. People thought these Treemaps, they looked cool. The ones I showed you before from the early ones looked kind of garish to be nice. Now the color palettes were really pretty amateurish. But we became more sophisticated as we came to understand the ways of representing data in these two-dimensional formats, a very different way from hierarchical data. And so, encouraged by people who said, these look so nice, you should make t-shirts, or you should make ties or coffee cups. And indeed, you can see my coffee cup is right here.
Oh, there you go.
This one serves as my pen holder. But yeah, the coffee cup or other designs were not innovative. So this one shows some data from Last FM, a music station, and the different colors represent different kinds of music, and the size indicates the popularity. And so these, we use the color palette from Piet Mondrian, whose images are widely known. And this one turned out to be my favorite, which is why I turned it into a coffee mug. And it's just strong, bold colors and shows off the virtues. It's an interesting one, and it's a visually catching one. I think you have some others there. You can see these images, by the way. Each of them were printed 24 by 36 inches, and there was text description on the side, and you can see the artistic influence. This one, business data, used the color palette and more or less the design of Joseph Albers, a famous color artist of the mid 20th century. This one was quite popular with business people, and it became the cover for an important book on macroeconomics. the authors chose that for their design. So we built these. Oh, here's one more. Well, yeah, this one called Urban Blues was a simple pattern based on Gene Davis's style of paintings, and these show a set of countries. Each country is one rectangle, and the area of the country was the population, and the color was the degree of increasing urbanization. And this was a startling one that popped out of the data. So I think if I tell you these are arranged alphabetically from left to right, I think you're going to guess that the biggest rectangle is China. And the next one a little further over is India. And further along, we see this surprising anomaly, a pink line. What is the pink line about? Well, it was
Oops. I think we lost Ben. Michael, did we?
Did we lose Ben?
I think so. I don't hear him. Do you hear him?
No, I do not.
Okay. Oh.
Okay. Well, look, Jose, why don't you continue on and talk to the folks about how you took some of these visuals and extended the data that Ben used in 2010 to create a sequence through 2020 of some of the data sets. Do you want to walk through that, Jose?
All right, sure. So we recreated those bands Treemaps, and this is the Urban Blues. And we created a little animation here from 2010, and we can see how that changes through the years. And then you have suddenly some of them pop out. That was Germany, and this one Japan. You know, the ones in red that Ben was talking about. And then China, of course, with the population, high population, you can see it increasing, and also India right here. So that's all the way up to 2020. Now we can continue talking about the big urban population. Is a similar one, and the coloring was done in 4 equally dense bins and using a linear scale. And this data comes from the World Bank's website, and you can see that it's all updated all the way to. You can now, in this case, you have a slider. You can slide through different years, and it's up to date until 2025. And you can see how the data changes through the year. And this is 2020, and then you can see the population, and the color population is the density of the people, and then yeah, you can just browse and see each one of them. There's another one that I really like, this Out in the Air. And again, that data set was collected from the U.S. Energy Information Administration. It also has the CO2 emissions. Actually, I updated. This is the one I updated up to date, and you can see the metric tons CO2 per person for all countries on those 7 continents. So you can see each of these rows is a continent. This is China, the biggest, the widest, and then you have the Europe, and then Africa, Central and South America, Eurasia, Middle East, and North America. So Asia and Oceania and North America are the biggest ones in CO2 emissions. So we can see as we cycle through, the color also changes, and the colors were inspired also by James David. Apricot Ripple, that's an artist. And you can see the color changes and the CO2 emissions, and also the size of the boxes changes as we go. And suddenly we see different colors as well as the CO2 emissions get higher.
And Jose, this one is a little bit different in the sense that it has rows of data as visualizing the hierarchy. So this is part of your work leading up to the Marimekko or mosaic chart analysis, right?
That's right. This came through the visualization mods. We have over 55 visualization mods, and you can find them in the community page. If we go to the to the community page, and then we go to the exchange right here, and then you go to visualizations. You will find all different visualizations that are available, and one of them is the Marimekko chart. The Marimekko chart is similar to the tree map, but it has two axes, two for categorical axis and two for right here, a continuous axis. And it's similar to a bar chart, but it uses stack bars in various widths. So this is useful for different use cases. So we're gonna talk about that.
Yeah, and some folks call this a mosaic plot or a Mekko plot. But the idea, if you got that extra category that you use on one of the axes to explain an additional variable.
Yeah, we'll see a couple of more use cases. This is you can see the different sectors for almond lovers, varied buyers, carrots and more, and delicious and new. Maybe that this could be products and stuff, and then you can see the percentages by stack based on each state.
And that CO2 emissions one really takes this to another level by looking at all those countries across the world, right? 170 countries, wasn't it? You visualized in that one?
Yeah, something like that. I have it. This is the urban the CO2 emissions.
Yeah.
Let me bring it. Where is it? Right here. Yeah, this is the CO2 emissions. 224 records.
224 countries, I guess.
Countries. Yeah.
Right. Okay. And so being able to look at that across time with those categories of countries and emissions gives you a nice sort of sequential picture of how that CO2 emissions have been changing per country across time.
Right. Yeah. And then you have a little map here that you can also check out. Also colored by country, representing the tree map on the right.
Right.
Okay, so let's move on to different use cases. We have different use cases, and for that, we also have our Dr. Spotfire team with us. We have Atir Alatar, and we have Boris, and we're gonna cover each one of us different use cases for the industry.
I'm back here. I don't know, it dropped out before.
Hey.
Oh, there you go. You're back, Ben. Thank you.
Yeah. Can I take just a minute? You were asking me a question about, the Museum of Modern Art story. So we made these 12 tree maps and these large posters, framed them nicely, put them up for an exhibit around the University of Maryland, and that drew a fair amount of attention, and that was great fun. One of our visitors was from the National Academy of Sciences, and he thought these were wonderful. And so he arranged for them to be displayed. We printed up another 12 of these large posters. He framed them, and they've been at the National Academy of Sciences, both in the Washington, D.C. and the Irvine, California campuses. And then the Museum of Modern Art came calling, and they knew about tree maps from their visualization exhibits on one called the Elastic Mind, which had some things like this. And so they were very happy. And we printed up a third set, and I traveled to New York and presented them to the Museum of Modern Art. So I'm not exhibited at the Museum of Modern Art, but they're in the collection of the Museum of Modern Art, maybe to be exhibited at some future time. And then many others, including Michael O'Connell. So these are cool, and arranged for a set for Spotfire, and other universities around the world have bought them. They're available free. You can download and print them if you like from the treemapart.wordpress.com website. You can see all 12 of them, download whichever ones you want, and print them up for your offices or hallways or home. So it's available, it's free, and I'm happy for that.
Thank you, Ben. As a matter of fact, I have one in my office. When I recreated this in Spotfire, Michael was kind enough to send me one of those printouts, and I have it there in my office right here.
And I have one in my music room. And if Jose, if you refresh the deck and go down to slide 30, we now have several of these up in the engineering headquarters office in Gothenburg. You might need to refresh the deck, Jose, because I just uploaded some photos. But it's the slide right before this that we recently had a bit of a ceremony in Gothenburg office and inducted those up to the
it's wonderful. I see you have the stock market. Oh, there we are. That's nice.
There they are. So they're hanging in one of the break rooms in the Sweden Gothenburg engineering office. I kind of took through those ones you gave me, Ben, across and gave those to Ollie Landstrom, who'd been the head of engineering for the last 25 years or so. We had a bit of a ceremony and we put them up in the engineering office there in one of the break rooms. So that's they're enshrined there, as well as in my music room and in Jose's study.
Yeah.
So
well, that's a great story about how it's traveled far and wide. You show the examples of the stock market, and finviz.com is a website that uses it for stock market visualization. And I find that to be one of the very fruitful ways of understanding what's happening in the markets. But Treemaps have spread far and wide. They became part of Excel in 2014, and so it traveled quite widely through users who had easy access to it through Excel. The Spotfire version is far more elegant and more features and has good sliders with it, so it can do some nice visualization tricks. But anyway, I'm pleased you've taken it the next step, as we say.
Absolutely. And go back one slide, Jose, because I think you just updated the tree map last night with the data from the valuations on the stock market right now, right, Jose?
Yeah, right. That's right. That's exactly right.
So and the area, as you show here, is the market capitalization. So it immediately stands out that NVIDIA and Apple are way up there. Microsoft and Alphabet are somewhat after, and then Amazon, Tesla, Broadcom, others, and the sort of notable rise of Eli Lilly into the $1 trillion circle of corporations. So they've done very well. They're green, showing increased value in the past I'm not sure what time period for the year. All right.
Yeah, no, it's quite popular in portfolio analysis, this visualization. You can see the categories there: technology, communications, consumer, financials, healthcare, and each the sizing and coloring of each is kind of within each of the categories.
Yeah, that's great.
Yeah.
In the early days of Treemaps, I was consulting for New York Times in New York, and they began to use them quite ambitiously. And there was a remarkable one, which is a full page of the New York Times, folded out. It was a great piece to frame, and it showed all of automobile and truck production in the U.S., and you could see which ones were going up and down, and which models were popular. So
cool.
It has many virtues. And the Global Burden of Disease is another popular website that shows the impact of different diseases over time. It has a especially rich set of data and very nice sliders and visualizations that are used by medical researchers and public health analysts.
Interesting.
So lots of nice story. Very satisfying. It's a rare moment and a satisfaction when you have an idea that travels so well. Actually, there's one other story. At the time, in 1991, too, there was great competition for the hierarchical visualizations. There were two that came from Xerox PARC, Palo Alto Research Center. There was the cone trees, which was a three-dimensional visualization, and hyperbolic trees. And we had a real competition going on. And these companies, what a difficult challenge. They were well funded by Xerox. They had patents to lock in what they did. They had money to launch startups. And here I was in this academic role, no patents. I did not patent it at the time. And so, it was a challenge as to whether I could succeed with Treemaps versus hyperbolic trees versus cone trees. And very satisfyingly, after these 35 years, hey, Treemaps are alive and well, and the other two have disappeared. And so it's one of those cases where not patenting was probably a good idea, because it was a novel idea that needed many improvements and variations, which others brought to it. And so keeping it open invited innovation, and that was a lesson that was pretty important to me. And I'm pleased to say by now there are many more patents on tree map variations than there are on the other kind of tools, and those have faded, whereas tree maps remain strong.
That's fantastic. So Jose, just go back to the slide where you list the different use cases. That just will show Ben a little bit.
So we have different use cases, two for energy, one for manufacturing, one for finance, and we're going to talk really quickly for that. And for that, we have our industry expert, subject matter expert Atir talking about this one.
Thanks, Jose. Yeah, this is an example of using the tree map for portfolio analysis or like asset evaluation. So what we are looking here, we're looking at three basins. For example, we have the Gulf of America basin, the Permian basin, and then the Bakken formation. And then within each basin, we have different formations. So for example, the Gulf of America, we have the Appomattox, and then the Mars, and then Thunder Horse. And then the same goes for the rest of the basins. So this is a great example of looking at different levels of the information at once. And also, it's another great example of drawing quick insights. For example, we can, just by looking at the visualization, we know that, let's say, the Bakken formation has the most diversity. So it has, let's say, the most expensive formation, like the most valuable formation, like this Saanich, and then the least expensive one. We can also conclude that the Gulf of America, for example, has the Appomattox, which takes the highest share of the assets. So this is a great example of looking at different levels and then drawing insights quickly from the visualization using the tree maps.
Very good. So this is just showing the oil and gas basins that have been developed in the U.S. and the Gulf of America over the last many years.
Yeah.
So absolutely. And we got another one in energy, right?
Yes, this is the Marimekko Chart, a use case also from the exploration expenditure, or like the capital expenditure in general. So what we're looking here, we're looking at different, let's say, location or geo markets or business units. We have Asia Pacific, Europe, Latin America, and North America. Now the width of each let's say channel or like bar refers to, let's say, the amount of the spending, or like the amount of the capex that is spent in the geo market. Within this geo market, we have a breakdown of the, let's say, the spending categories. So we can see that, for example, Latin America spends the most on drilling, while Asia Pacific spends the most on maintenance. We can draw conclusion. We can draw, let's say, insights like Latin America that almost spend zero on maintenance. And then that goes for all the, let's say, the rest of the geo market. So this is also like another great example of visualizing information in different categories, and also being able to break down within that category into subcategories, and then quickly draw insights and conclusion by just looking at the visualization.
Excellent. I think Boris has got an example in manufacturing too, right?
Yeah, absolutely. Thank you, Michael, and hello, everyone. I've got this manufacturing data here, and it's a very good example how tree maps actually present manufacturing quality data as a hierarchy of colored rectangles. So you can see how the chart is segmented by product line. We have assembly tools, automated systems, and engine components. And within each of those product lines, it's further broken down by a specific defect type. And then the size of the rectangle is actually the total defects reported for the product. And then we can add one extra dimension. In this case, the color gradient represents the cost of quality associated with fixing the defect. So here we can see that for assembly tools, we have calibration issue, which is actually the biggest by volume. However, it's not the most, it's not with the highest cost. Actually, the highest cost are material flow, wear and tear, and software bugs. And we can see we have the whole spectrum of the low color is the low cost, and then the blue color is the low cost, and then orange is the high cost.
Fantastic. So it's great to see that diversity of use cases shown through the tree map and Marimekko. and to the all the way to the current day with the NVIDIA just overtaking Apple for the highest valuation product.
Yeah, we also see that the giant like United Healthcare went down like 2%, and also Goldman Sachs 1.8 down in the final say.
Right, and that just pops out with the red color, right?
Yeah, that's right.
Yeah. Well, cool. Back to you, Jose.
So yeah, we have. I don't know if you want to cover this.
Oh yeah, so I just wanted to kind of acknowledge we've gone all the way back to the beginning of Ben's career, and just wanted to close out our conversation with Ben with his latest work. And it's fun to have you kick off your book at one of our conferences a few years ago, Ben. And it seems like human-centered AI was a little bit ahead of its time, and a lot of stuff has been happening since your book came out. And I certainly followed the Google group Human-Centered AI with the URL at the bottom of the page, and lots of stuff that's relevant to right at the minute coming out through that Google group. But Ben, maybe you can talk a little bit about what happened in that Google group.
The natural outgrowth of my work in visualization and human-computer interaction was to think about AI and its role. And when I was writing this book, when the book was published, I feared that it would be soon out of date. But actually, it's more relevant than ever before, and the number of citations to this book just continues to soar each year that goes by. The focus of human-centered AI is to ensure human control while increasing the level of automation. That's seen as a real challenge to people, but Spotfire is a terrific example of a human-centered design because the user explores the data. You can have AI embedded in Spotfire to provide recommendations, guidance, and so on, but then the user is the one who does the exploration. Human-centered design is also about building user self-efficacy, supporting their creativity, clarifying their responsibility for what they do, and then supporting social connectedness. And recently, as I've been talking about this, I've used Spotfire as an example because we built features in there that enabled Spotfire charts to be easily exported in different formats and supported the social connections among people who were working on visualization and business problems. And so those ideas from the Spotfire world became central to human-centered AI, and that topic continues to grow. I would say we're still a minority position where there are people who believe that the machines should be autonomous and they should be intelligent and that they're agentic. But for me, there's no I in AI, or there should be no I in AI. It should, those chat GPTs should not be saying, I can do this, or how can I help you? That idea eventually tires, and users want to be in charge, have the sense of self-efficacy, enable their creativity, know they're responsible, and then be socially connected. So that's what good tools from digital cameras and Spotfire and Bloomberg interaction, Bloomberg terminals, all support these ways of using AI that keeps humans in control.
Absolutely, and I think here we've got a quick example of how you've been working on that with the human controlling Spotfire and conversing with documents and reports to bring insights into the Spotfire analysis, right? Is Zathir able? Can he join and show this bit a little bit, Jose? Or all right, I can show it if he's not around.
Okay. Sure. You want me to advance the other slide?
I can speak to it. Yeah. So just basically the setup here is we got a lot of these daily drilling reports from the contractors operating a drill site, and we arrange those in AWS through a knowledge base graph database called Neptune, as well as an open search vector database. So we tokenized and stored those data, and then go to the next slide. And then we, inside of our Spotfire Copilot, we allowed you to have a conversation. So the Spotfire Copilot comes up on the right. You can now ask some questions of that. For example, let's see, can you make that a fuller screen, Jose? I can't quite read what's happening there. Okay, create a data function to analyze
last files from external URL.
Back, Mike.
URL, yeah. So Althea's back. Althea, can you talk to this?
Yeah, sure. This is an example of using the Copilot in Spotfire to create a data function to analyze last files, and then also do some calculations on the gamma ray to calculate the V shell. So in here, we're just asking Spotfire Copilot, hey, create a data function to calculate the V shell, and then output two versions of the tables, one long version, one let's say wide version, and also smooth the data, and then calculate the V shell. And then the Copilot will proceed to doing all of that, and then asking the user to kind of like approve creating data functions. And then after that, a data function will be added with the complete code. And then the user only needs to map the inputs and outputs. And then you can see in the example that the whole code came out commented and then ready to work. And then after we analyze that, we use the well log visualization mod here to visualize the data that we brought using a data function in the Copilot. And then also, I just wanted to point out that with the 14.5 now, you can natively interact with the last files. You don't need to write a data function for that anymore. But you still can use the Copilot to help you with creating all the data functions, and then also asking questions about the data that you're interacting with.
Well, fantastic. And now you've got the production joined into the analysis. So when you click on the site where the well is actually producing, you've linked to the production data, and now you can make a relationship between the gamma ray of subsurface that shows the volume of shale in the subsurface, and you can compare that to the production.
Yes.
So all of that coming through a chat interface with the Spotfire analyst in control of the analysis and surfacing the insight to others.
Yeah.
Okay, Jose, wrap it up.
Yeah. Unfortunately, we don't have enough time, but we're gonna prepare something special, maybe regarding the latest and greatest features of a Spotfire, including Copilot. I always thought that Spotfire has always been ahead of its time, and we've been using AI since it was even before it was even popular. But I'm glad that we are all here, all the Dr. Spotfire team here, Boris, Atir, and me. This is the office hours, the first Tuesday of every month. If you cannot attend, the sessions are recorded, and you can watch them later, make your comments, and we can follow up. Then the Dr. Spotfire session, I'm going to skip through that. It's just how the Dr. Spotfire program works, and that we have everything recorded. This is our YouTube channel. And finally, you're welcome to send us feedback for new demos or data functions, scripts, mods, whatever. If you don't want to contact through social media or the community, you can always contact directly at drspotfire.com, because you might not want to share publicly what you're going through. And with that, thank you very much, everyone.
And thank you so much for joining us today, Ben. That was a lot of fun.
It was. Thank you.
Thank you. Bye-bye.
Bye.
Bye.